Welcome to SolidCAM Professor on a series of Getting Started. I'm Sydney, your SolidCAM Professor, and in this part we'll be showing the use of multi-sided machining. If we were to take a look at this particular part that we see on our screen here, you'll note that we have to machine this part on the top surface. We have to machine it on each side as well. We will be grabbing this part on a 5-axis machine, doing indexial machining on every single one of these sides. Let's just take a look at our coordinate system manager. If I were to open it up, you'll see that my first home and my second home, third home, fourth home, and my fifth home position are all in Mach 1. This means basically that we have this all being machined in one clamping operation. Now let's take a look at our stock, and our stock in this particular case is the actual casting of the part itself, as you can see over here. So we're actually getting this part as a casting part. Now let's take a quick overview of the machining that I've done on this part already, and then we'll go into it into more detail. First of all, I've machined it, as you can see, on all my different positions. My first position, I've actually machined the face on top. And then I've decided to do the drilling on the side of the part itself also, as you can see here. And I've repeated these drilling steps, including the milling of this top circle over here, on all sides. Same thing over here. Same thing on the fourth side, as we continue around the part itself. Now let's go back and take a look at our first operation. First of all, our first operation is in position 1. If I were to open the operation that I've done here, we'll see that our coordinate system is Mach 1, position 1. And my geometry was the face itself. If I were to take a look, my geometry is the actual outside boundary of the top face. I do not have to take the entire part, since I am working, as I said before, on a casted part where I do not have to machine. There is no material to machine on the outside, just this face itself. Now the tool that I'm using in this operation will be a 16mm end mill, and my upper level will be 0. 0 simply meaning that my upper level, my home position, is actually above the part itself, being on the stock material itself. And my face depth is 2mm below that. If I were to click on the face itself, you'll see that it'll be going down 2mm. Now in my technology area, since my tool is smaller than the whole face itself, I'll be using the technology of hatch, going back and forth. And in my data area, I'm just telling the tool to go 110% past the part, and on the sides only go past the part by 15%. And I'm having an overlap of 30% of the tool as it's going by. Now I'm also doing this with a floor offset of 0.2mm, and then also finishing on the floor. If I were to do save and calculate and simulate, you'll note, if I put this on my top view, my tool is going down, going across, cleaning the top of the part, and the top of this part is now machined. if I were to look at my simulation using Solid Verify, you'll see that the tool, I'll slow down the simulation a bit, goes down, across, and fixes the part. Let me just do it now at one step at a time. You see the tool goes down, cleans, and that's going to take the rest of the material that's left over, another 0.2 millimeters, and it's completely machined the top of this part. Now let's take a look at the rest of my operations. This particular operation I've done before was in Mach 1, position 1. Now my next set of operations, will be in Mach 1, position 2. And what we'll be doing over here is simply drilling out this hole, and also on this surface we'll be using a profile operation to clean that up. Let's just take a look at the operations that we've done. In this particular drilling operation, I've simply used an 8mm center drill, as you can see here. And I've gone down a total depth of 3 millimeters from the cutter tip itself. My next operation, I've used the same technology, but instead I've used a different drill, a 10mm drill, to go all the way down to the drill depth, which is at the very bottom point over here, as you can see. Now, with the technology in this particular operation, I've used the drill peck option, going down every 2 millimeters. If I were to do save and calculate and simulate, and again use my Solid Verify simulation, you'll see that I have the center drill already done over here, and my drill will go down. Let me just get rid of the holder so it'll be a little clearer for us to see. And it's pecking the entire part as it's going down. Now in our next operation, what I've done here is I've used the exact same technology, exact same geometry as I used before, but this time I changed my drill to a 17.5mm drill, which is the diameter of the hole that we have here. As you can see, 17.5mm. The levels, I've gone down to the exact same depth that I went in the previous operation. And again, in my technology, again I am using the peck drill cycle. Again, if I were to go into my simulation and use the Solid Verify simulation in the part, you'll see that I'm going down one step at a time. Let me just get rid of the holder so we can see it a little better. The tool is going down. And completely drills out the part itself. Now, if you remember correctly from the part, what we still have left to do is to make that little spot on the top, as you can see over here. And this I've done in our next operation using a profile. Simply choosing my geometry being the circle around itself. The tool, I'll be using a simple 16mm end mill. And my level, my profile depth is up until the surface itself, as you can see here. In my technology area, I'm using a direct finish cut on this. And my link, I'm using a link of approach, lead in of arc of 2 millimeters, and the same as my lead out. Again, my technology, I'm using finish. Another thing can add in here also is have my extension over my overlap, say another millimeter. This way, when my tool goes around, it won't stop at the exact point where it starts, but it'll go a little past it and then go out with an arc. If I were to do save and calculate and now simulate the operation itself, the tool will go down, work its way around, and finish the entire operation. To get rid of the holder and just do this one more time, the tool goes down and mills out the entire step that we see over there. Now, in our next set of operations, what we've done here is very simply. We've just changed our position, as you see here, but the technology is the exact same technology that is needed as we did over here on these sides. We have one hole to a specific depth. The only difference here, the depth is different, but this spot here on top is the exact same thing. The diameter is the exact same diameter. So we basically use the exact same technology for each one of these operations, just like we've done in Mach 1 position 2. And we've done the same thing also in position 4 and in Mach 1 position 5. If I were to take a look at the simulation, and the simulation, I'll do it from the very first operation until this particular operation here using Solid Verify. You'll note that the simulation is done. Everything is done. Each side according to that particular tool, according to that particular hole. The technology is the exact same thing, just the position is different. Now, in my next set of operations, back to Mach 1 position 1, what we've done here, we've completed these holes over here on the top surface, and we've also completed working on these holes over here. If I were to take my first operation over here, we've done a profile, a pocket operation, and my geometry in this particular case were these actual holes here. We decided that since these holes had to be exact, we decided to do it using a pocket operation. Also drilling it, since the hole goes into an existing hole, it wouldn't be the best idea to drill it out, so we decided to actually mill out those holes itself using the pocket operation. If I were to do the simulation of this particular operation, you'll note that the end mill will be going in, and the way it's going in is actually going in using a helical movement into the hole and milling it out and completing all the holes as you see here. Now, in my next operations, I will be dealing with these holes, which are simple drilled holes, and I'll also be dealing with these two holes here that are step holes. With my simple drill holes, very simple operation. First going in with my 4mm drill, drilling down the hole itself. And my next operation, again, I'll be using the same geometry. Just take a look at the geometry itself. Those 4 particular holes over there. And my tool will be a 5mm tool, but this time it'll be a flat bottom tool, because I need a flat bottom on that particular area over there. And the depth will be going down 10mm. And in my next operation, I'll be going into these two holes as you see over here, and I'll be using again my 8mm center drill. Just to take a quick simulation look at this operation. I'll do it one step at a time, getting rid of the holder itself. And as you can see, the drill is going down, jumping over the part, and then drilling out the second hole itself also. If I use the 3D simulation, you'll be able to see the exact tool path over the part itself. Tool goes down, jumps over the part itself, as you see here, and then goes down on the other side, completing the operation of the center drill of those two holes. Now obviously my last drill hole would be again using the same geometry, but using the proper tool, being a 6.6mm drill, to go all the way down to the bottom. In my levels, you'll note that I'm going down 15mm plus a little more. And my last operation, to complete this spot area over here, I've simply done a simple profile operation. As you can see, my geometry over here, using 6mm end mill, and the levels going from this level here down to a total depth over there, which is a total of 2mm in depth, as you can see my profile depth. If I were to do again my simulation and use my solid verify simulation, you'll note that the tool will go down, clear this area over here, as you see over here, and on this particular side over here itself. Now with all these operations that we've done here, we've completely machined my entire part using the multi-sided machining option that we have within SolidCAM itself, using a 5-axis machine in Dexial. In this particular case, we're having it machined first the first side, as you see on top over here, then each side individually, and finally going back to the front side and completing my task over here. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.